To program ESP boards or Arduino boards, we generally first write the code in the IDE and flash it to our development board. But with the advances of AI agents, you no longer need to write and flash the code manually. Now watch what happens when I just ask an AI, turn on the single RGB addressable LED on pin 38 to switch colors one by one in 1 second interval. Within seconds, the code is built and flashed on your ESP board and output is also visible. That is the power of ESP-Claw, which is an Espressif's take on popular OpenClaw AI agent framework. This is the chat coding AI agent framework built by Espressif officially for IoT devices. ESP-Claw doesn't need any IDE to flash the firmware. You just need a Chromium based browser such as Chrome or Edge, as it needs a web serial API support. Hello everyone, I'm Hariharnath and welcome to IoT Frontier. Today we learn how to simply chat and run a code on our ESP32 board. So currently ESP32S3 and ESP32P4 are only supported boards as per official site. By the end of this video, this ESP32 board will be receiving natural language commands from Telegram-like messengers, does reasoning with an LLM, and performing various coding tasks and remembering my preferences. In the end, you'll also get some tips and tricks to efficiently use this tool. So let's get started. So I can quickly go through some of the important features of this ESP-Claw. So with this ESP-Claw, you just need to type your query. For example, you use Telegram like messenger and then type what you want. For example, you want LED to be turned on and off for 5 seconds interval. You can simply type and it creates a Lua code live on ESP32 with the help of LLM that you will be providing. Second is event-driven architecture. ESP-Claw can react to your messages. For example, in our tutorial, we'll see PIR motion sensor. Whenever it detects a motion, we get an alert. And the important thing is you don't need any cloud to save your memory. So all the memory will be stored inside your ESP32. So another important thing is dual MCP identity. So this ESP-Claw makes your ESP32 device as MCP client as well as MCP server. Another thing is you can use 3-tier event handling. For example, you get an event, you first write basic rules which are local, and based on that it will decide, and if it cannot be decided by local, it uses LLM reasoning, so that is tier 2. And then if there is a complex inference like images, etc., it can also send to the cloud, that is tier 3. Now that we have seen the important features, we'll go through the flashing technique. So as I said, there is no need of any other toolchain or IDEs like Arduino IDE. You just need ESPClaw.com. If you are getting in Chinese, you can simply click here to modify into English. So first you need to connect your ESP32S3 to USB and then you need to click on connect. So you will see this. So for example, if you don't see this kind of device to be connected, then which means that driver is missing. You can simply search for CP210X VCP driver from Silicon Labs. You can download it. Once you install, you can click on this. So when you connect, you will be seeing two different firmwares. First is ESP32S3 DevKit C1, another is with breadboard. Because we are connecting different sensors with breadboard, etc., for me this has worked. So I suggest you to click on this. Next thing is you need to provide your Wi-Fi SSID and password so that it connects to the internet. Next thing is the LLM service. So for this LLM service, I'm not using any of these cloud platforms because I don't have the paid subscription for using the APIs. So for this, I have a workaround. So I'll use OpenAI compatible API and try to download Ollama. So Ollama is for having your models on your system. So first you can simply download this Ollama. So once you download, Ollama will be loaded like this. And here you can see various models that are available. So you can simply download a local model, but when I tried using local model, it was having some issues in the speed. So what I tried to use is a model that can be fetched from the cloud. So on the top you can see the cloud models that are available. So you can use any one of them. I will suggest you the best one to use. So after this, you also need to modify a few things in the settings. So make sure you connect to your account in the cloud so that you will be able to use the cloud models. And then you need to click on this expose Ollama to the network so that our ESP-Claw running in this network can access this Ollama APIs. So this is the important thing that you need to do. And also make sure you enable this cloud toggle button so that you can use that. Ollama supports this OpenAI compatible API. I'll simply use this one. And in the API base, I'll have to use this. So this is the IP address of your laptop. So you can see the IP address of your laptop and then use that as HTTP, and the port is 11434, which is exposed by Ollama, and version 1 you need to provide here. And the Llama model you need to use is Gemma 431B cloud. So this has worked properly for me. So you can go to Ollama, go to models, and here you can click on this and you will find the local versions as well as the cloud versions. So you simply copy this and then you can paste it here like this. And second thing is API key. Because we are using Ollama locally, you don't have to enter it, but because it is mandatory, you can simply write Ollama here. And then you need some messaging platforms like Telegram. So we click on Telegram and we need to create a Telegram bot token. So to get the Telegram bot token, first you need to search for bot father in Telegram and then use this new bot so that it will create a new bot, give it a name, and also you need to give a username that is ending with bot. So once we enter this bot username, it will be saying that your bot is created, and in the below I can find the token. So I'll copy just that token. So once the token is created, you also need to provide a search engine because some of the things it has to search. But they are suggesting Tavily because it provides a free tab. So you can simply click on this, open Tavily dashboard. You just have to register and then you'll be redirected to this page, and here you'll be getting a key like this. You simply copy here and paste it here, and now click on flash firmware. So if it is not starting, you just have to click on boot button in your ESP board. And another important thing that you need to use is, in generally you will be having two USB ports on your ESP32. One is labeled as USB, another is labeled as UART. So for me it has worked with UART. So you need to use that UART. Now you can see the console, and in the console you can see the flashing has been completed in 123 seconds. So I'll simply disconnect here. Next thing important is you can simply open this Arduino IDE and open serial monitor, because serial monitor you can monitor the important values that are coming. So I'll simply select the board and port, dev module and this. So I'll get something like this. So it is trying to initialize everything, and in the starting you can see some of the important things like, so it might have connected to the Wi-Fi, it might have started MCP, all those things can be seen here. So I'll use this side-by-side view to just show you the chat. So I'll click on this ESP-Claw bot and click on start bot. So you can also see some of the important things here. So whenever we are able to see the start, it is saying ESP-Claw is snapping on it, which means that your ESP-Claw is ready to help you, and the event messages can be seen from here. So first we'll try to ask what is its status. So immediately on the left side you can see some of the important details that are coming, and the conclusion will be given. So there will be so many rounds generally happening. So this is simple command, so it will use one round, and you can see what is the uptime, what is the hardware, CPU utilization, RAM, network. You can also see the Wi-Fi and the IP address of this device, ESP device, and what is the signal strength. Next thing is we'll try to create a buzzer control. So I'll just say that I have connected active buzzer to the 12 GPIO, and it has to make some music out of it using time duration. Because we are using active buzzer, it can only use time duration to make the pattern of sounds, and don't stop until I say stop. So this is a bigger program, so it has to go through the different skills, so it will go through different rounds. So you can already listen to the rhythm that it has created. So you can see how fast it has created. It all depends on your LLM response as well. So for example, if I first try to use the local Gemma 4, it was taking so much of time. So that's why I switched to the cloud Gemma 4 and it was able to give me quick responses. So while the buzzer is on, I'll simply ask it to again do another task, that is to make my single RGB addressable LED, which is on GPIO pin 38, to blink in rainbow sequence of colors in half-second interval. Let's see how fast it can create. So now I can already see that it has already created the rainbow color sequence. And also you can see the buzzer is also coming. So which means that the buzzer and the LED program are two different programs that are simultaneously or parallelly running in different threads or tasks. So that is how cool with this AI agent framework. Now before proceeding, I'll simply ask it to stop this LED. So now it has stopped and come to a halt with a single color. Now I can also ask it to stop the buzzer. So we got an information that it will stop in a while. So now let's go to event driven architecture and perform a demo on that. So for this, I'll use a PIR motion sensor which is connected to GPIO 14 and monitor the motion and send an alert if you detect a motion. There are three things that we asked it to do. First is to detect the motion and then use the buzzer to beep the alarm, and then it can also send an SMS or alert to your Telegram. So three things it has to do. Let's see if it can do it without any glitch. So now we can see it has already taken from the memory that I have connected 12 GPIO as a buzzer because I haven't provided it in this command. So it has taken from memory and then also will be sending a telegram. So let's do a demo of this. So I kept the hand and I got the buzzer, but I didn't get an alert on Telegram. So I can simply ask it to fix. So if I just type like this, it will try to fix this. So it is going through different rounds to fix this. So now it is saying it has corrected. Let's see. Now I try to put my hand in front of the motion detector, but still I'm not getting the alerts. So I can go on like asking to clear this and fix this. So it will do that. So sometimes there are some glitches because of the LLM as well as this ESP-Claw, which is just in the early stage. Now we can also try to check the memory test. So I can simply ask it to create a reminder for a meeting at 10 AM today. So I just asked it to create a reminder. So let's see what it does. So it is saying that it has created a reminder. So 10 AM today, it will give me an alert. So another important feature of this AI agents is MCP. So ESP-Claw supports both MCP client as well as MCP server. So it can act as both. So I'll simply show you a quick demo on that. So for that, I'll use VS Code. So in VS Code, I just logged into a Copilot. So once the VS Code is open, you simply have to use this in this and to open the chat. So this is VS Code Copilot. So you need to first log in into this and register that. And once you have done that, you click on this customizations. In the MCP servers, you need to click on plus icon. So if you click on this plus icon, you will see these options. So what are the different ways of MCP? So we are using HTTP because that is how this ESP-Claw is set up, and then provide the MCP server. To find this, in the logs you can find the MCP server URL. So I have already noted that. So you can provide the ESP-Claw.local. You can also use the IP address of it that you can get from chatting, and you can also use this MDNS name, and the port is 18791 and the MCP server. So you need to press enter, and the name you can provide ESP-Claw MCP server, and I'll put as global. So now you can see this MCP server is running. So I can go back and then type here. So I can simply ask, what are the tools? ESP-Claw MCP server. So let's see if it identifies this MCP server and goes through it. So it has properly identified the tools. It is having device describe, means you can ask for the host state, endpoints, everything, and no parameters are required. And device report state, you need some parameters like device ID, state, value parameters, and also like router emit events, you can also provide some events to it, like it requires these parameters. So I'll simply ask it to describe the local MCP server host state and endpoint using ESP-Claw MCP server. So it will ask me to allow for this session because it has to go through that MCP server. So it ran and found me these are the different values. So like this, you can use multiple tools that are available here and provide different parameters to make sure it works. Now we have come to the last topic, that is tips and tricks. So once you have started and deployed the ESP-Claw, you will be able to see its access point. You can use that access point URL here, or you can simply type espclaw.local. It will open all the settings that you have provided, like configuration of Wi-Fi, LLM, instant messaging, etc. All these things can be seen here and can also be modified. For example, if I want to use something like a different model here, I'll simply change here and provide Llama 3.23b, and in the memory also you can see what are the different things that it has stored. So long-term soul, identity, everything can be seen here, and what are the different files it has created. For example, different scripts we have asked in our session, so you can open that folder and see what are the temporary files. So you can see OLED, buzzer, motion monitor, RGB rainbow, everything has been saved in this temporary. Now if you want to modify this and save, you can simply save changes and it will say it is saved, and you can restart by using the reset button on your ESP32 to save this. So another tip is, so in the ESP-Claw Flash online page, you just disconnect, because if you disconnect only, you will be able to see the logs in Arduino IDE. So if I close this Arduino IDE and again connect here, the previous values will be intact. So if you close this and open this again, like refreshing this page, you will see that those will be gone. So another trick is, like, you need to use the popular models, like which are having good reasoning capability. So most probably use the cloud models so that you get a best result. And since ESP-Claw has recently arrived, you may expect few glitches here and there, and which will be fixed by them soon. And that's all for today. We have learned how to simply chat on Telegram and control an ESP board. This is just a glimpse of a future world. So stay tuned for more updates by subscribing to our channel and hitting the bell icon. If you found this video informative, please type helpful and smash that like button. Thank you for watching, and I'll see you in another interesting video.